Hello, here is my second video on unit circle trig. We're going to talk now about angles of any degree measure, and along with that, something called coterminal angles. When I say any degree measure, I'm referring to the idea that you can now have angles that are, you pick a number, -4 million. There is now an angle that is -4 million degrees. And when I say now, I mean that previous to talking about unit circle trig, that would have been a nonsensical thing to claim that there's a -4 million degree angle. Because in regular geometry, you'd think, wait, how does that describe how two rays relate to each other? That doesn't make any sense. But now we can think about a new way of defining angles. So here is an example of, let's sketch in standard position. This is this new term for angles. These angles, we'll do three of them. Number one, let's do an angle theta. That's our default name for any angle. We're going to say theta is equal to 190 degrees. We'll do that one. And number two, we're going to say theta is equal to -460 degrees. And then in number three, we're going to say that theta is equal to, let's see, how about, how about 620 degrees? Is that what I want? Yeah. So look at these three angles, and well, let's look at the first one. Theta equals 190. So the idea on this is that every time you sketch an angle in standard position, it's exactly the same process. You make a picture of the coordinate plane, an x-axis and a y-axis. You start by drawing what's called the initial ray. There's always two different rays for any angle, but when you're in standard position, these two rays are very different. One is called the initial ray, and it's always, always, always starting at the origin and going in the positive x direction, making it red. And then the second angle, I'm just changing colors because I think it's helpful. That second angle for 180 degrees, don't think about where it is. Instead, think about where it goes. It's motion that this implies. We start on top of the initial ray, and we think of a rotation being described by this number. The rotation is positive, therefore it is counterclockwise, meaning we're going to go this way. And we just kind of count out how far we're going. We know that's 90 degrees, that's 180, so we need to go a little further, about 10 further degrees. So we just eyeball it, and we always draw an arrow that starts on the initial ray. It doesn't have a little arrow there because it's going in this direction. And then there's an arrow down there, and we mark in theta equals 190. And that is a good picture of this particular angle. For theta equals -460, we follow the exact same procedure. Make an x and a y axis. We start with the initial ray, which again, I'm just going to keep color coding things just to keep this all nice and consistent and understandable. And then this one's negative. Now again, I do want to remind you, before you learned about unit circle trig, before you learned about angles in standard position, this should have meant nothing. It should have been meaningless, like a negative degree measure. What does that mean? It now means something. All the negative means is, instead of rotating this way, you go the opposite way. And so we rotate this way. And we can count it off as we go. We're going 90 degrees. 180 is this way. We're just adding 90 each time. 270. And notice I'm not making a circle because I don't want it to go over on top of itself. It's a corkscrew. That's 360. And I'm only 100 away from what I want. So that would be 450. And about 10 degrees past, exactly 10 degrees past, I have my terminal ray here of the angle. And I need a little arrow right there showing the rotation. And that is theta equals, and you can put it anywhere, theta equals -460. Now notice that the actual angle itself is just the two rays. And I want to notice, if I hadn't put in this rotated corkscrew thing, and I'd ask you, what's the angle measure of this red and blue angle? You wouldn't be able to tell me, because you wouldn't be able to know how the rotation worked. You might have wondered, well, maybe it had gone this way, maybe it had gone the other way, maybe it spun around 5 times. It's absolutely essential that you draw a picture of how the rotation worked in order to tell me what this angle is. Now let's see what's going to happen with this one. So on this one, 620 degrees. I paused there in writing that number because I was doing a little mental math. I wanted to make sure that something happened. So hopefully it'll work out. Special thing. Let's do the same procedure. We're going to make this initial ray, and now we're just going to make the terminal ray. Now it's a positive number. Theta equals. It's a positive number, so that means we're going to rotate counterclockwise this way. And I'm just counting up. 90, 180, 270, 360. Now I can keep going. 360 plus 90, maybe you don't want to do it this fast in your head, but you can put it on a calculator and think about it. 450, 540, 630 is this far. So I've gone around a full, 1.5, almost 2 times, but I'm at 630, so it's a little short of that. It's about 10 degrees, it's exactly 10 degrees short right there, which means that it points down this way. And the arrow I'm going to make, again, goes like this. It goes around once for 360, and then a second time around, and it ended up there. And that is theta equals 620. Now I'd like you to think about something about these two. I set it up this way. When I did the negative 460 and I was counting backwards, I realized I had to go about 10 degrees past here. When I did the 620 and went around this way, I realized I also was about 10 degrees past here. In fact, exactly. In fact, you guys, if you're really on this, will notice these two angle measures actually produce a location of the terminal ray that's identical. They're in the same spot. Now they are different angles because they got there in a different way. I'm not saying that these angles are literally the same thing. I am saying that they've ended up in the same spot. And that's a big distinction that's new. Old angles, before you talked about this new definition, in old geometry, if I had two angles that were in the same spot, they're the same angle. That's changed. These angles are different because they got there in different ways. But the fact that they land in the same spot seems to bear some notice. We should notice that. And there's a definition here that's a very important one in unit circle trig. The definition is if two angles have the same terminal ray, like these two do, the terminal ray is in the same spot, but different angle measures, like these two, then we call them as a pair coterminal angles, which should make good sense as a Latin prefix. Co meaning with, so the two angles are with the same terminal ray. Coterminal angles, which I'm underlining there because it's a definition. Here is a question that I want us to answer before we move on to the third video in this series. How can you recognize numerically, just by looking at the numbers, how could you recognize that these are coterminal without actually drawing them? Obviously, when we drew them, we noticed it. But the question I have now is, how could we notice just from these numbers? And I want you to think about what was true about how many spins there were here. Notice that the amount of spins that you'd have to make to spin around and to land one of these on the other is going to be some 360s. It's going to be spins made of 360s. These are off by some number of 360 degrees. And so, if you notice, negative 460 has 460 degrees to get back to 0, then 620 more degrees. If you add 460 to 620, you get 1,080, which is 3 times 360. And so, to cut to the chase here, the idea is if theta 1 and theta 2, so I'm putting subscripts here to distinguish them from each other. This is just two different angles. If they are coterminal angles, then if you take the numerical value of theta 1 and you subtract it off from the numerical value of theta 2, if you find the difference between them, like 620 minus negative 460, then you're going to get some is a multiple of 360. It's a multiple of 360 degrees. So a final example in this one is different than these, but a related problem. So here's the fourth problem, is to answer this question. Are theta 1 equals 500 degrees and theta 2 equal to 780 degrees, coterminal or not? Are they or aren't they? Now, one method for doing this would be to actually draw them and do the kind of things we did here and try to figure out if the rays are in the same spot. But a simpler way is to use this numerical key. All we have to do is take theta 1 minus theta 2, or theta 2 minus theta 1. It doesn't matter, you can do either one. But we're doing 500 minus 780, which is negative 380, which is not a multiple of 360. They're not 360 apart. Or 720 apart, or 1,080. It's a multiple of them. So no, these are not coterminal. They don't land in the same spot. All right, that's a good start. Go to the third video and you'll learn some more about Unisur's pull trig.